into the middle of our single linked list. So let's say, for example, we want to insert a new node between Mick and Johnny, and we'll call him Bruce. So we create a new node, but we basically want him to we want it between the nodes for Mick and Johnny. So let's just very quickly, can I jump back, and I'm going to take a copy of a blank node. So I'm going to copy him. I'll jump back and I'm just going to paste him in. I'm just going to drag him up here just for a minute. Okay, there we go. So node objects, I'm going to give him a unique memory address just to show that it's a unique object in its own right. And I'm going to call it A at 0007. Doesn't matter. A unique object in its own right. So we said that we're going to set its value, so we can set its string value to and we said, what did we say? Bruce. So we're going to add in Bruce. So what we're going to do is we're going to follow the numeric notation that if Mick is in position 1, Johnny's in position 2, and Timmy's in position 3, we want to insert Bruce into position 2. So basically Mick is at 1, Bruce will be in 2, and Johnny will be in position 3. So following this notation, we can identify that we want to store Johnny into position 2. So we will, what we're going to do is we're going to use our current and previous pointers to point at our objects for us. So the current object we're dealing with is position 2, which is Johnny. So I'm just going to set this value. Let's make that a bit bigger so we can see it. Okay, and the previous object was Mick, and his memory address is A at of 0004. So basically we're just holding pointers to these two objects. Now it's important that we maintain or hold these objects. What we're going to do is we're going to have to break the chain between Mick and Johnny, break the chain between Mick and Johnny, insert our object called Bruce, get Mick to point at Bruce, and get Bruce to point at Johnny. So we have already we've held on to our 2 pointers. So now we're going to start into the operation. So the way it's looking already is that Mick knows how to point at Johnny. So the value stored in Mick is of use to us. We are going to introduce our new node. So our new node, Bruce, now needs to point at Johnny. But Mick already knows the value of how to point at Johnny. So we can go for the object, which is A out of 0004, which is this object here, already stores the value of how to find Johnny. So we're able to take or to copy this value, and we can assign it or add it to the pointer that's stored in the new object for Bruce. So we're taking this value and putting it here. So what this has done now is that it's telling the object named Bruce how to find the next object in the chain, which is our object called Johnny with a memory address of A out of 00001. So that's the first step. So Bruce is now pointing at Johnny. So I'm just going to take an arrow just so we'll know, and we'll tell Bruce to point at Johnny. So he's already pointing at Johnny right now. So now what we need to do is we need to tell the object named Mick not to point at Johnny anymore, but we want him to point at Bruce. So we can basically say we can tell the object called Mick to point at the memory address of the object called Bruce. So we reassign the value here. Now what this has done is breaking the chain. So we're not telling Mick to point at Johnny anymore. Actually, I need that. We're telling our object called Mick to point at Bruce. So basically we've broken the chain, and what this has done for us is it's actually managed the insert of our new object. So we've gone from head Now, head points at our object A out of 0004, which is Mick. Mick points to Bruce. Bruce points to Johnny. Johnny points to Timmy. Now, obviously, from the previous example, I just removed an object just to make it easier to explain the example. The last item in our list should have contained null. So we've gone from head to Mick to Bruce to Johnny to Timmy. Timmy holds a pointer value of null, which is basically indicating the end of our list. So if we just want to tidy this up ever so slightly and see the chain in one direct action, and just move our friends over here ever so slightly, make a bit of space. So Bruce points at Timmy. So you can see the memory addresses match up. So I'm just going to very quickly copy our friend down, just pull him down, and reconnect our chain. So the memory addresses match up. You can see that Mick's value points at object 007, and the Bruce object, his pointer points at of 0001, and the chain's maintained. So head starts here and it goes through the memory addresses. So each pointer to next knows how to find the next object in the chain. We keep going until we have a value of null, and that's basically the end of our single linked list. So that's the basics for initializing and the three positions of adding. So we can add to the end, we can add to the start, so it's add to the very end, add to the front, or add to the middle. So we've run through the three examples of how to add to a single linked list. Now when it comes to our implementation, we will need to basically cater for this programmatically to be able to cater for adding to the end, adding to the start, or adding to the middle. So obviously we'll have different logic depending on where we're inserting to our single linked list. We'll cover this later in our programming example. So next, we're actually going to look at how to actually remove something from a single linked list. If we're going to be removing from a single linked list, it's going to follow the same principles of add. We can either remove from the very end of the single linked list, we can remove from the very front, or we can remove a node from the middle. So based on this, similar enough to add, we need to be able to remove an object from the single linked list. And once when something has been removed, we need to be able to reconnect our pointers to make sure that we haven't broken the chain of basically our chain of objects. If we mess up the pointers between the objects, we'll have lost data and we basically have destroyed the integrity of our single linked list. So the first thing we look at is how can we actually remove a node from the end of a single linked list.